Hello everyone, I am Mr. Ashok Kumar. In this video I am going to briefly explain you about the project Dynamic Resolution of Image Edge Detection Techniques among Sobel, Log and Canny algorithms. Okay, all I am going to do in this video is briefly explaining you what actually we are going to do in this project. I am not going to explain you how we are implementing that, okay, because there are a lot of other prerequisites you need to know before getting into the detailed implementation part of it. Okay, so I request all of you people to explain this project as it is for your college coordinators as well, but definitely they're going to come back with few questions like tell me more about algorithm, tell me more about the framework or anything like that. Okay, so any questions they ask, promptly reply them saying you need 1 or 2 days of extra time to answer all those questions because you just started to learn this project, you haven't completed it or mastered it everything. Okay, and all those questions asked by your coordinator should be immediately redirected to me on this number or on this email ID. Okay, so once I answer to those questions, you people can go ahead and answer it to them. Okay, so let's get started now. These are the things that I'm going to explain you in this video. First let me explain you something about the summary. Okay, summary is nothing but a kind of quick facts about this project that you need to know. Okay, and prerequisite or the some basic knowledge before we getting into the project related stuffs, existing systems and the problem statement, like what constitutes our project, what led to come up with this idea, and then what are we going to propose in our project and its advantages, and at last hardware and the software requirements. Okay, so now coming into the summary of our project. So summary, I will call it as a quick facts. Okay, these things anybody at any point of time they might ask you, so you need to keep these things ready. Okay, so first they might ask you like what is the domain of your project, in which particular domain your project comes under. Okay, and where did you get this idea from. Okay, what is the base paper to your project, where did you get this idea from, like that. Okay, and what are the algorithms you are going to use in our project. Okay, and then what amount of database you people are going to use in our project. Okay, so like that they might ask you and lot of other questions like what is the framework you're going to use, like that. Okay, so now to answer all those things, the domain of our project will be in image processing, that. Okay, and the base paper, I mean we got this idea from 5 different IEEE papers. Okay, this is the important thing, and this is the power of your project actually, where usually the project will be from one single IEEE paper, but here for this particular project we have 5 related IEEE papers. Okay, I can provide you all those papers. I think you will be receiving it in the email from me. Okay, so we will be picking up the concepts from all these papers, and then we will be implementing it. Okay, so and the algorithms we are going to use in our project happens to be the Sobel algorithm, the Canny algorithm, and then the logarithmic transformation. Okay, so these are the 3 core algorithms we are going to use in our project. Apart from these 3 core algorithms, we also have a lot of other algorithms as well, which you will be mentioning it in the the development classes. Okay, but as of now it's okay to say that you are implementing these 3 core algorithms. Okay, and the amount of dB we are going to use is only 3 to 4% of dB. The reason why I am saying this is because VTU has a limitation saying that you cannot use more than 20% of dB. Okay, we are in very safer side because we are using only 3 to 4% of the database. Okay, why we need this database is only to store the login credentials of the user. Okay, anybody who wants to use our product, they need to log into our product and then they need to use it. Okay, to store this login credentials, we are going to use some amount of dB, and it constitutes only up to 3 to 4% of it. Okay, and the framework we are going to use is Windows Builder. Okay, this is not a browser based application, instead this is a kind of Windows Builder application. Okay, so we are going to use AWT APIs for that. Okay, so Windows builders and AWT APIs actually provide an interface, the user interface screen for externals or anybody who wants to use our project. Okay, so these are the quick facts you need to know about this project. So now coming to the prerequisites, one prerequisite you need to know before we start our project related stuff is something called edge detection technique. Okay, so probably you would have heard about this term anywhere, the image edge detection technique. So I can say that image edge detection technique is nothing but a mathematical operation which will be identifying the points in a digital images. Okay, one example I can give you is, if an image contains a world map, if you apply an edge detection algorithm to it, so it will identify the roads and individual individual country boundaries will be identified over there. Let me open a browser here and let me show you how image edge detection works. So if you could see in this particular image towards the right bottom of the screen, so there's a photo of a girl over there. The left hand side one is the original image, and applying the edge detection algorithm will give you the image shown towards the right hand side. Okay, so you can clearly notice the edges over there. Each and every edges has been identified, and it will be shown in the resultant images. Okay, so this is what we call the edge detection technique. Okay, now let me tell you some of the important applications of edge detection technique, like to demonstrate where exactly it will be useful. Okay, so one important application of edge detection technique is in enhancement of noisy images. So if there are any images that is not clear, contains of huge amount of noises and all, this edge detection technique will be applied to remove all those noises, to identify only the valid portion of the images. Okay, so an example for the noisy images will be images from the satellite. Satellite images can be used for removing the noises, and X-ray images, the images of any scanning report, like that. Okay, these images we can be used for removing the noises within it. Okay, and second application of this will be in text detection. Like if there is a text within an image, you need to extract it. Okay, so for extracting the text within an image also we can use this edge detection technique, and also it will be used for video surveillance. So the meaning of video surveillance is video monitoring. Like if you want to identify which are all the objects that are moving inside a video or something like that, if you want to monitor CC camera footage and all, we can use this edge detection technique. Okay, and there are lot of other application as well. Okay, but we can mention these three things as of now. Okay, now let us come to existing systems. So in the previous slide I just explained you some concept about image edge detection algorithm. Okay, so here I am going to mention what are the available algorithms that can be used for finding the edges in a digital image. Okay, I can say that there are three most popular algorithms called Hebbal algorithm, Canny algorithm, and logarithmic transformation. So these algorithms could be used for detecting the edges in a digital image. Okay, so there could be many other algorithms as well, but as far as our project is concerned, we will just stick on to these three algorithms. Okay, so and also it will not be possible to understand the entire working of these three algorithms at this point of time. Anyway, you are going to learn it during our project development time. Okay, but as of now, what you people should be focusing is that the fact is Hebbal algorithm will be working fine for some input images, whereas Canny algorithm will be working even better for some other set of images, whereas log will be working fine for some other set of images. Okay, in other words, I can say that Hebbal is better than Canny for few images, whereas Canny is better than Sobel for few other images. Okay, there is no universally accepted fact saying that this particular algorithm is better for all the types of images. We don't have an algorithm which is better for all the types of images. Okay, so who will make this decision? User is just going to input an image. Who will make the decision which algorithm should be executed? So this decision making is the most complicated one, and that happens to be our problem statement. Okay, so at the end we need an efficient algorithm which finds out the edges very clearly. Okay, but as I mentioned now, Sobel, Canny and log have their own advantages for different set of input. We need someone who will make the decision of which algorithm should be used, right? So this happens to be our problem statement. So if you want me to write it down, I can say that we couldn't determine well in advance which algorithm should be, or I can say which algorithm is best suited for an image in consideration. So if you can read out this statement very clearly, it says that we couldn't determine well in advance which algorithm is best suited for an image in consideration. Okay, user is just uploading an image, but how will you decide which algorithm is best suited for that particular image? We couldn't find it out. Okay, so this actually is the problem statement in the existing system. Okay, let me recall everything. So in the existing systems we have three different algorithms for finding out the edges in a digital image, namely Sobel, Canny and log. Okay, the problem statement is that Sobel will work better than Canny for some images, whereas Canny will work better than Sobel for some other images. Therefore we couldn't determine well in advance which algorithm is best suited for an image in consideration. Okay, so this happens to be our problem statement. So for solving this particular problem, what we are going to propose is we are going to implement an end-to-end product, or we call it as a readily usable software. I call it as a readily usable software because without any extension, customers can readily use your project. Okay, we are building that end-to-end product. Okay, and this product will be dynamically resolving the edge detection techniques. Okay, so you people should be getting a brief idea now. What we are going to implement in our project is we are developing a product which will be accepting an image as an input, and it will dynamically select which algorithm should be used for the input image. Okay, how we are going to do make this decision, you cannot understand at this point of time, but just remember the term called PSNR. Okay, so the expansion for PSNR is peak signal to noise ratio. So this will be the parameter that we are going to use. Okay, so based on this peak signal to noise ratio, we are going to determine which is the best algorithm to be used for an input image, and then we are going to execute that algorithm. We are going to find out the edges within that image, and then we are going to provide it as an output, right? So basically in our project we need to implement all those three different algorithms, and then we need to come up with a intelligent logic which will be finding out the best algorithm for an input image, and then we need to provide an output. Okay, so commercially this will be having lot of value because we are making use of multiple algorithms, and then we are mixing up the advantages of each one of those algorithms. Okay, the advantages of each one of those algorithms, all those things and all will be aggregated, and it will be shown to you during the project development classes. But that's actually the power of this project, where we are going to implement three different algorithms. Okay, apart from basically what happens is your college coordinator or the external evaluator are going to ask you what extra you people have implemented apart from what is present in the IEEE paper. Okay, so for tackling those questions we are going to implement n number of other features as well. Okay, so say for example we are going to implement point processing techniques. Okay, we are going to implement morphology techniques, and then artistic techniques, and then spatial filtering. Okay, so we are going to implement these many other extra algorithms by ourselves. Okay, because we are building an end-to-end readily available software, right? So it should consist of all the features. Okay, so keeping that in mind, we are also going to implement these many extra things which is not present in the IEEE paper. Okay, so we can actually claim that we have implemented more than what is present in IEEE paper. Okay, so this is actually the proposed system and their applications. Now let us go to the hardware requirements. For implementing this project we don't need any specialized hardware, because this is not an hardware intensive project, this is a software intensive project. Okay, so a machine with these many configurations should be well and good. We need a machine with 40 GB and above hard disk, 4 GB RAM and above, and then dual core processor with 1.6 GHz and above. Okay, these are the minimum configuration we need. Okay, and coming to the software requirement, you can see here I'm going to show you the detailed technologies we are going to use in our project. So we are going to use some technologies in the front end, some technologies in back end, and some technologies in database side. So for storing data we are going to use MySQL, and for implementing the back end part we are going to use core Java and advanced Java, and for implementing the front end we are going to use Windows Builder and Java, AWT and SWT APIs. Okay, this front end is basically required for developing the interface which will be used by our end users, customers, for developing that wonderful screens and all. This backend is required for implementing our core algorithm. All the core algorithms will be present in the backend, and this database is for storing some application related data. Okay, like logged in customers username and password, their profile information, like that. Okay, so these are the software requirements for our project. So I think I am clear with this abstract explanation of the project. If you have any questions, please call me on this number, or you could also email me if you want the answers in the written format. Thank you so much.